Welcome, grade 11. Let's look today at the points of intersection of two lines. First of all, remember the different methods of solving simultaneous equations. We will be using that method like we're solving simultaneous equations. We are given two lines, and the two lines meet somewhere at a point, say, xy. So that is the common point for the two lines. So the best way to work out the equation, to work out the point of intersection will be for you to find the two equations, the equation of that line and the equation of that line, and then solve the two equations simultaneously. Let's look at one quick example. We have two lines, and the equations of the lines are x plus y is equal to 5 and 2x minus 3y is equal to 0. So we need to solve these two equations simultaneously to find x and y, and that will be the point of intersection. So I number my equations. I prefer to do that. X plus y is equal to 5 is my first equation. So that's equation 1. Then 2x minus 3y is equal to 0 is our second equation. I'm going to use substitution. So from equation 1, I can make either x or y the subject. I prefer y to be the subject, so y is equal to 5 minus x. So now we can substitute that value or that expression for y into the second equation. So wherever we see y in the second equation, we will put 5 minus x. So this equation then becomes 2x minus 3y, but y is 5 minus x. So all this is equal to 0. Remove the brackets and solve. You should get x is equal to 3. All right? Please do that and make sure that you get x is equal to 3. That is the first part of this task. The next thing we need to do now is to find the value of y using this value of x. We know that x is equal to 3, and so we can take that value of x and substitute it into either equation 1 or equation 2. I will substitute this one into equation 1, but I will take it from here because this is the same as equation 1. So to get y, we need to substitute for x in that equation. And so y will be equal to 2. Therefore, the point of intersection will be equal to 3 and 2. So these are the coordinates of the point of intersection. Right, example 2. This time we are given two lines. The lines are perpendicular, they meet at 90 degrees, and they meet or intersect at that point P. We need to know the coordinates of P. Right, let's use this method. Find the equation of the blue line as well as the equation of the other line, and then solve the two equations simultaneously. So for the first line, the blue line, you will notice that line passes through 1, 7, and it also passes through 0, 5. So we can make use of that and find the gradient of the line. So let's call it M1. The gradient of the line will be 7 minus 5, that is y2 minus y1, divided by 1 minus 0, that is x2 minus x1, and that will give us an answer of 2. Right, so that is our gradient. I'm using the form y equals mx plus c. So I want to use the form y is equal to mx plus c. So if I'm using y equal to mx plus c, the next thing I need now is c. But fortunately for this example, I know where the line cuts the y-axis. It cuts the y-axis at that point there where y is equal to 5. And now c, remember, is the y-intercept. So that means c is equal to 5. So we know c is equal to 5 from the diagram. So if c is equal to 5 and the gradient is equal to 2, then the equation of the line can be written as y equals mx plus c, which is 2x plus 5. All right, so that is the equation of the line. Let's call it number 1. So that is the first equation. The second thing we need to do now is to look for the equation of the other line. Right, that line we are given passes through the point 5, 0. Right, the line passes through 5, 0, and the line is perpendicular to the other line. So we know the gradient of the first line is 2. Therefore, the gradient of this line should be minus 1 over 2. Right, so the gradient should be minus 1 over 2. Remember, m1 times m2 should give you negative 1 because these lines are perpendicular. So if m1 is 2, then m2 should be negative 1 over 2. So we need to work out c here. Now to find c, I'm going to use y equal to mx plus c again. And I'm putting, for x, I'm putting 5, and for y, we're putting 0. Right, and so that will give us 0 is equal to mx, which is minus 1 over 2, multiplied by x, x is 5, all that thing there plus c. If you solve that for c, you should get 5 over 2. Okay, 5 over 2. So what is the equation? The equation, I'll write it here. The equation is y equals mx plus c. So m is minus 1 over 2 x plus c, but c is 5 over 2. Right, so this is equation number 2. So first of all, we need to work out the equations for these two lines. Then we solve the two equations simultaneously. Right, let's do that. Now it is clear from number 1 that the expression 2x plus 5 is equal to y. But from number 2, y is equal to minus half x plus 5 over 2. So it makes those two expressions equal to each other because we are solving simultaneously, remember. So this is this is 2x plus 5, which should be equal to minus 1 over 2x plus 5 over 2. Those two should be equal. Okay, so we are just taking equation 1 and putting it equal to equation 2. Right, now to solve that, we need to clear the fractions, multiply by the lowest common denominator, which is 2 in this case. So multiply everything by 2. This is 4x plus 10 is equal to minus x plus 5. Right, collect your like terms and solve for x. So the left-hand side will become 5x, and the right-hand side will become minus 5. Therefore, x is equal to negative 1. So x is negative 1. And now we need to find y. We take this value of x and substitute it into either equation 1 or equation 2. I prefer equation 1 because it looks less complex than equation 2. So I will substitute this value of x into equation 1. So let's do that. This means y is equal to 2 multiplied by x, but x is minus 1. All that thing there plus 5. All right. And that will give you an answer of 3. So the value of y is equal to 3. So what is our point P? The point P should have coordinates minus 1 and 3. All right. So that is our answer there.